Today, we are treating electrolysis. Electrolysis is very important in both physics and chemistry. What is electrolysis? Electrolysis is the chemical decomposition of a substance by the passage of electric current through its electrolyte. Please note that, write it down. Electrolysis is the chemical decomposition of a substance by the passage of electric current through its electrolyte. Note the following terms. We have what is called electrolyte and we have the electrodes. An electrolyte is a substance which either in liquid or molten state conducts electricity and are decomposed by it. Then we have what is called electrode. We have two types of electrode, the positive electrode and the negative electrode. Electrodes are plates and rods through which current enters or leaves the electrolytic cell. The positive electrode is like a plate. We call it the anode. And the negative one is called the cathode. Current enters the electrolyte through the anode and leaves through the cathode. We have the voltmeter. The voltmeter is a device for studying the flow of charges in an electrolytic cell. Let me sketch this electrolytic cell and show you some of those things. If we have this as a voltmeter, which is used for studying the flow of current through a liquid, this is the electrolyte, which is a substance that conducts electricity either in liquid or molten states and are decomposed by it. Examples of electrolytes, we have acid, base, and metallic salts. In past questions, you can have different acid listed, different base, then you have to classify them. Please, electrolyte examples, acid, base, and metallic salt. Then anode is the positive rod or plate, while cathode is the negative rod or plate. Current enters through the anode and leaves through the cathode. Let's look at Faraday's laws of electrolysis. We have the first law and the second law. Faraday's first law of electrolysis states that mass of a substance deposited or liberated at the electrode during electrolysis is directly proportional to the quantity of electricity passing through it. Mass is directly proportional to the quantity of electricity. Now, in mathematics, if we have mass and we change this to equal to, there must be a constant. That constant is Z in physics, and we call it the electrochemical equivalent. Z is the electrochemical equivalent. It's constant and it will be given. So from Faraday's first law, the mass of a substance deposited or liberated is very proportional to the quantity of electricity passing through it. And recall that Q is equal to IT. Q is charge. Quantity of electricity is equal to current times time. Finally, we have the mass to be equal to ZIT. Mass in kg, the electrochemical equivalent in kg per coulomb, and then the current in amperes and time in seconds. Let's take this example. Example 1, copper of mass 0.33 gram is liberated by passing 1000 coulombs of electric charge through a copper voltmeter. Calculate the mass of copper deposited when a current of 2 amperes is passed through the voltmeter for 5 minutes. So the first mass that was giving M as 0.33 grams and Q as 1000 coulomb. With this, we can say that M is equal to ZQ. Let's get the constant first, which is M over Q, and that would be 0.33 over 1000. Please be careful with the units. We are still using gram. That means we are going to have 3.30 times 10 raised to power minus 4 grams per coulomb is still in grams. So we have gotten Z. Now, when the time is giving us 5 minutes, T is 5 minutes, and current I is giving us 2 amperes. We will convert this 5 minutes and say 5 times 60. 5 times 60, that will give us 300 seconds. 300 seconds. So we are looking for, calculate the mass. We are looking for M. Remember, we already have the constant Z. And the final answer, we'll leave it in gram because our constant is in gram. Using MEZIT. MEZ, we have it as 3.30 times 10 raised to power minus 4. Current is 2. Time is 300. So the final answer, the mass we are looking for will be 0.198 grams. Faraday's second law of electrolysis. Faraday's second law of electrolysis states that the masses of different substances, remember this time around we are using masses of different substances deposited or liberated by the same quantity of electricity is directly proportional to the electrochemical equivalent. There are things you need to note in the second law. In the second law, the masses of different substances, you are comparing masses now, is directly proportional to the electrochemical equivalent of the substance. And in the second case, the constant is Q. By the same quantity of electricity, which shows that Q must be constant. Remember that in the first one, M is directly proportional to Q. But this time around, it has to be the same quantity of current. This is our constant now. So M is equal to ZQ. In the second law, we'll have it that M1 over M2 is equal to Z1 over Z2. So we have, let's say, silver, copper, silver, copper. That is why we have masses of different substances, but this time around by the same quantity of electricity. Let's look at this example. Example 2. What is the mass of hydrogen liberated in an acidulated water voltmeter if a current of 6 amperes flows through the voltmeter in 1 hour? Take electrochemical equivalent of silver as 0.001118 grams per coulomb, and that of equivalent weight of silver as 108. Let's write out all the parameters we are giving. Giving current as 6 amperes, time as 1 hour. We'll convert it. Remember, 1 hour is 60 minutes times 60 seconds. So that it will be 3600 seconds. Then we have quantity of electricity. Q will be IT. Remember, IT, that will give us 6 times 3600 seconds. So that we'll have the quantity of electricity to be 21600 coulombs. We were given that the electrochemical equivalent of silver are 0.001118 grams per coulomb. It means that 1 coulomb of electricity liberated 0.00118 grams of silver. Electrochemical equivalent for silver is this. Remember, it's grams per coulomb. It means that 1 coulomb liberated 0.00118 grams of silver. The calculated one that they are asking for 21600 coulombs will be this times this. What will it give us? So if we multiply that, we are going to have it to be 21600 times 0.00118. These things are very simple. Just understand it. If we multiply that, we are going to have 24.15 grams. So we have gotten the mass. Now, remember, what is the mass of hydrogen? What is the mass of hydrogen? That's what we are looking for. And the weight of silver was given as 108. So we'll say mass of silver over mass of hydrogen. Mass of silver over mass of hydrogen will be equal to the chemical equivalent of silver over the chemical equivalent of hydrogen. Mass of silver was given as, we calculated it as 24.15. Remember that hydrogen, mass of hydrogen is what we are looking for. Mass of hydrogen is the unknown. Then electrochemical equivalent of silver, 108. And that of hydrogen, hydrogen is 1. Remember your chemistry. This has to do with physics and chemistry. Then let's cross multiply to get the mass of hydrogen. If we cross multiply, we'll have mass of hydrogen gas times 108 is equal to 2415. So that the mass of hydrogen gas will be 24.15 over 108. And our final answer will be 0.224 grams. 0.224 grams. Before we take assignment, let's look at the following applications of electrolysis. It's very, very important you note it. Please write them down. 1, electroplating. That is the coating of a metal with another metal. Purification of metals. Extraction of metals. Go and find out. If you're doing purification and extraction of metal, which one is which of them will be placed as the anode or the cathode? All these are very, very important. But I don't want this video to be too long. Please turn the bell notification so that when I'm explaining more things on this, you will follow through the class. Electrolytic reduction of metals from their compounds. Calibration of ammeter and production of chemicals. Please try these assignments to know if you're following and if you can get the question. Question 1. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be, look at the options given, try it and choose the correct options. Another question, the electrochemical equivalent of platinum is 5.0 times 10 raised to power minus 7 kg per coulomb. To plate out 1 kg of platinum, a current of 100 amperes must be passed through an appropriate vessel for A. 5.6 hours, B. 56 hours, C. 1.4 times 10 raised to power 4 hours, D. 2.0 times 10 raised to power 4 hours. All these are from JAMB past questions. Please try them out. Remember to like this video, subscribe to this channel, turn the bell notifications for more videos. Thank you.